If I'm looking at the next example, example 3, where we need to evaluate the integral of, let's see, we have x squared minus 1 on top and x cubed minus 3x squared minus 10x at the bottom, dx. All right, and here's a question to you guys. What will be the first step? What approach will take here? Can we do substitution here? The answer is no, because if we take, for instance, if you're looking to see if the numerator is the derivative of the denominator, it's not. Okay? If you take the derivative of the denominator, you have 3x squared minus 3 minus 10. Actually, I'm sorry, 3x squared minus 6x. And if you multiply here by 3, you have 3x squared minus 3. So we are missing a little bit. We probably could have dealt with the negative 10 at the end, but so the answer, what Matt suggested, because we have a rational function here, and it's a proper rational function, then integration by part will do the trick here. All right, so integration by partial fraction, I'm sorry. So partial fraction will be the strategy. Okay. Can we factor right here? Well, we're going to say, first of all, we factor, so we have x cubed minus 3x squared minus 10x, x times x squared minus 3x minus 10. Okay, and the 2 and 5 will give you 3, so negative 5 and so it will be x times x minus 5 times x plus 2. This will give you negative 10 and negative 3. So at this point we're saying that x squared minus 1 over x cubed minus 3x squared minus 10x will be the sum of the partial fraction, and we have 3 factors, so it will be a over x, and all of them are linear and none is repeated, b over x minus 5 and c over x plus 2. Here, because we have 3 different linear factors, the solution for ABC would be very simple. I don't think we're going to need to to solve a system here, because if you multiply by the common denominator, then you end up equating numerators. Say x squared minus 1 is equals to a times x minus 5 times x plus 2, b times x plus 2, and c times x minus 5. Okay? And instead of clearing the parentheses, you can say, you know what? What happened when x equals 0? When x equals 0, the b and the c disappeared, and what you have here is negative 1 equals negative 10a. Okay? Because everything else disappears. So you get a equals 1/10. We pick up x equals 5. So when x equals 5, you have 25 minus 1. On the left side, you have 24. On the right side, let's see, this disappears and this disappears. What's left is the b term. and you have 5 times 7, right? So you have 35b. Wow. 5 times 7. So b equals 24 over 35. We cannot reduce it. And then when x equals, we'll make it -2. Okay, here we have 4 minus 1, so we have 3 on the left. -2, this goes to 0, this goes to 0. What's left is the c term, and you have -7 times -2, so positive 14. So 3 equals 14c, and therefore c equals 3 over 14. Notice by the result we have kind of fractions. It probably would be a whole lot more work to solve it by low echelon reduction, or even if you put it in matrix, you have a bunch of fractions coming out of you. So in this case, just picking up 3 convenient values, it's easier to find out the coefficient a, b, and c. So now the integral I originally was x squared minus 1 over x cubed minus 3x squared minus 10x dx. Now looks like the integral of, and then a is 1/10. So 1/10 times 1 over x, right, dx, and then the next one is 24. Actually, I should have put it outside the integral. The coefficient can be factored outside, like so. And then factor out the 24 over 35. Integral of b is, we have dx over x minus 5. And then, no, nothing is negative here. And then plus c, which is 3 over 14, integral of dx over x plus 2. And those are easy integrals to calculate.